Hi and welcome to this Storm Performance Showcase. In this video, we will compare base Unity performance to Storm performance in a large 2 by 2 kilometer scene, rendered in URP in a low-poly art style. The scene was originally built with procedural tools as a test environment for a shooter game. We will load up the Unity version of the scene first. Take a note of the loading time. This took roughly 6 seconds to start up. The next thing you'll probably notice is that the performance is not very great. We're only getting about 20 frames per second when looking at the horizon. Only when we look up and down, so that fewer objects are visible, do we get more FPS. When mimicking the perspective of our game on ground level, the performance is consistently bad, since usually the player would look towards the horizon constantly when navigating the scene. Keep also in mind that this is just a static scene, not a game yet. Once additional game logic, enemies, and VFX are added in, this would quickly become unplayable. Let's now take a look at the Storm version of this scene. The first thing you might notice is that the scene loads significantly faster. It took only about 2 seconds, as opposed to 6 seconds with Unity. The second thing, and this is much more important, is that we are now getting great high frames with Storm, while the scene is visually almost identical. Storm achieves this by automatically creating LODs for your content and applying advanced rendering techniques when dealing with such large object counts. When we take on the ground level perspective again, we now have good performance with plenty of reserves. This will be more than enough to add in our game logic and other actors. If you're targeting low-end devices or developing heavier scenes, you have an additional advantage. Since all the content in this scene is rendered through Storm, you can easily tune your performance directly in the game by adjusting parameters for different content categories. You could, for example, decide to reduce the drawing distance for large objects like buildings, or reduce their LOD bias to draw lower detailed objects earlier. Likewise, you could argue that we do not need to draw small objects out that far and bring them in closer, which would additionally help with performance. This was a first glimpse into what you can achieve in terms of performance with Storm. Keep in mind that performance is not the only reason to get Storm. It is also a procedural spawning tool, allows you to import geospatial data, comes with its own terrain system, and much more. We will introduce these elements in more videos soon. Thanks for watching and see you in the next one.